Hello and welcome to another 3D survey tutorial. Today we'll check out the process of point cloud registration in 3D survey. Point cloud registration is a process of aligning two or more overlapping point clouds into one. So let's say we have four non-aligned point clouds that we got out of our terrestrial laser scanner. First, we load them all into 3D survey. Start an empty project and just go to point cloud, browse for your data and click open. Once they are loaded, you should see them on the screen. You'll notice they all fall into the same coordinate origin. They were taken on a different spots, but since the scanner doesn't record telemetry, they have no info about coordinates or rotation. That's why they end up on 000 coordinate. To illustrate that, we'll quickly draw a circle here and give it those coordinates. Okay, so this is the point where all the standing points fall to. Now let's get those point clouds properly aligned. We'll start with point clouds 1 and 2. To start, find the manual registration button in the bottom row. The manual registration window will open up. Here you have two windows. The left one displays a point cloud that's going to be aligned, and the right one is the reference point cloud. First, zoom to the vantage point of your point cloud, so you see what you saw from the standing point. Do this for both point clouds. The alignment works on a set of identical points, so you have to find at least 3 points that are common to both point clouds. A pretty easy and obvious choice would be this corner. Mark it on both point clouds. Now let's continue with the second point. Let's pick this corner on the upper level. If needed, increase the point size to see better. You can do this separately on each point cloud, like here. For now, don't mind the error numbers. Let's find the third point. Let's pick it on a car. Just make sure it's well visible on both point clouds. I will choose this headlight corner, like so. And now that we have 3 points, we can inspect the error numbers. They're all well under 2 centimeters. And now we're almost done. There are some additional options here in the center. You can fix the scale and lock the z-axis. I have both of these on because my point clouds are all from the same source and on the same elevation. When you click register, you'll be taken into the transformation preview. We can check our result if we toggle on and off one of the point clouds. Here are the transformation parameters, and a very important notice, keep this box unchecked. Later we'll see why. Now let's examine our results. I think we can be pretty happy with them. So, one thing you can notice is the circle remained here where the point cloud 2 has its origin. That's because it was the reference cloud. Now let's continue with the third and then the fourth point cloud. Again, we go to manual registration. Now, as I mentioned before, the left point cloud is the one that we are aligning, and on the right is the reference point cloud. So, it is very important that we get this right. With the current settings, we would be transforming the already aligned point cloud 2 to the coordinates of point cloud 3. This is not what we want, so we have to switch here. Now we set the point cloud 2 as a reference point and the point cloud 3 as the one we are transforming. Okay, now let's repeat the known process. Zoom in on the left and zoom in on the right. See where you'll find your points of alignment. I quite like the rocks, so I'll zoom in and find one here. I increase the point size to make it easier for me, and do the same on the right side. This might have been too big of a step between the standing points, but we'll manage it and not worry too much about it. For the sake of this tutorial, I won't be looking for a perfect point, so I'll just try to pick one, let's say in the corner of this window. It's a bit harder on the right side. And always try to place the third point out of the plane of the first two. So perhaps somewhere on this car would be nice. It would be ideal if I could get it in the target up there, but I don't have that luck. So let's pick a feature that's visible on both point clouds, like this rear light. And let's check the error again. Not great, not terrible. For now, that's more than enough, and later I'll show you how you can improve that. Let's just hit register and check how our alignment looks from afar. Seems good. So we could just click confirm here. But I want to make a quick pause here just to warn you about this checkbox. If you had this on, it would mean that you would like to transform all your elements according to this transformation, even those that you already aligned with the previous transformation. So now that that's out of the way, we can safely confirm and move on. Okay, now that's 3 out of 4. The last one we'll do super fast. Are you ready? Let's go! And we're back. I confirmed my last transformation. Take a look at my final results. I'll turn on the other point clouds. And that concludes our manual registration of point clouds. And now it's time for detailed inspection of our accuracy. To do that, I'll use the bounding box tool. We crop out the unwanted points and focus on our object. The best way to check accuracy of such cases is to check for double walls. And so we'll slice our building with our bounding box to get a nice cross section. And here you may already see hints of double wall. But for clearest image, it's best to filter out the ground points also. This makes it much easier to see, but there's another trick I want to show you. A very simple one, using simply just a select tool. So select all the point clouds in the area we would like to compare, and they all come out in different color shades, which makes it so much easier to see the differences and discrepancies in alignment. Again, let's increase the point size a bit to emphasize this even more. And now we can clearly see that this is not what we want. So we need to take a step further. But before we go there, let me just show you another trick how you can visualize these discrepancies. Select the point clouds you want to see and assign them a custom color. I suggest something flashy that stands out, something of contrast like yellow, and for the other one, let's pick magenta. And as a final step for this alignment, we'll use automatic registration. But before we go into that, let's take a measurement of just how big of an error are we talking about right now. I'll select the 2D distance in the CAD module and take a measurement between the yellow and the magenta wall. Like this. So it's a 7 centimeter error. Okay, back to point cloud. You'll find the automatic registration button in the bottom right corner. A new window opens up which lets you set the reference cloud and the clouds you want to align to it. We set the mode to normal and just press match. Depending on the number of point clouds and the points in them, this could take anything between a minute or an hour. The algorithm works on a principle of minimizing the distance between two points that represent the same area or object on two different point clouds. The mode that we set in the previous step defines the number of iterations. Anyways, let's speed this up a bit. So in about 2 minutes we got the result, and here we will see the difference immediately. We can see that the gap between the walls is reduced, but still present. For the purpose of this tutorial, we'll repeat the measurement here and go over the process again. This time we'll set the mode to precise, which usually takes more time since it does more iterations. But since we're starting off from a very small misalignment, the process was over in less than a minute. So now we finally got our walls merged together. We can return them to their natural color and see the complete result we got through this point cloud registration process. So there you have it. We successfully registered our non-aligned point clouds to fit together perfectly. And now you know just how to do it yourself. Remember, this feature is only available in 3Dsurvey scan module, so go check that out if you haven't already. It also brings you tons of other features for working with point clouds either from scanners or photogrammetry. Thanks for watching this tutorial and see you next time!